Hi guys, welcome back to our YouTube channel. In today's video, we'll be looking at this given simultaneous differential equation. This is a differential equation. We're given 1 and 2. So I'm going to be solving it simultaneously. So now to solve this problem, we're going to be applying just three simple processes or principles. So the first one is we're going to be applying and transforming these equations into Laplace domain. So we're going to be transforming into the Laplace domain. We'll transform it into the S domain. Then that's the first process. And the second process is the manipulation phase. On this part, we are going to be manipulating with the new domain that we have transformed into, that is the S domain. We are going to be manipulating and try to simplify it. So then the last process and the last stage is to take it back to the original equation as it was. That is, we're going to be applying the inverse Laplace transform. So don't forget, the first process is the application of Laplace. We're going to be applying Laplace to both equation 1 and 2. Then we manipulate the variables that they have. Try to simplify partial fraction, whatever things that are necessary to manipulate. Then the last step is by inversing it, that is taking the inverse Laplace of whatever we have manipulated. So now let's start. As you can see, we're given dx dt is equals to 3y plus exponential t. Then the second equation is dy dt equals to 12x minus t. And then we're given some initial value, which is x of 0 is equals to 1, then y of 0 is equals to 1. So now to solve this, we need some basic principles and some basic knowledge. So, and like I said, so now if you want to apply Laplace to this derivative function, is give us s of x minus x of 0 Laplace to x. This x now, this x is a function of time. As you can see, this is t. So x of t. When you apply Laplace transform to this, you get our x of s. Then when you apply Laplace transform to dy dt, you get same thing as this, but this time it will be y of s minus y of 0. Then when you take Laplace of y of t, that is this y is function of time, we're going to get the same thing as this y of s instead. So these four idea will be very useful going forward in this solution. So let's proceed now. Now let's apply Laplace to both equation. So now applying Laplace to dx dt is equals to 3y plus Laplace of exponential t. So then for the second one, Laplace of dy dt plus Laplace 12x minus Laplace of t. So now this, when you take the Laplace of this will give us Laplace of dx dt. Like I said, this is s, not 5, please. X of s minus x of 0, then is equals to Then we know that 3 is a constant. You can bring the 3 outside of the Laplace. And Laplace of y will give us what? Laplace of y of t, which is what? Y of s. So they multiply by the 3 that's a constant. So we have 3y of s. Then Laplace of exponential t. So Laplace of exponential t, we have done something like this in our last video. So Laplace of exponential t will give us 1 over s minus 1. So now for this second equation now, Laplace of dy dt is going to give us s y of s minus y of 0 is equals to the Laplace of 12x. So 12 is a constant, bring it outside of the Laplace. Then Laplace of x, that is x of t, we say it is what? X of s. Then minus Laplace of t. So Laplace of t will give us what? Now you know that the standard of Laplace of t raised to power n is always 1 over s raised to power n plus 1. So Laplace of t will give us 1 over s square. 1 over s square. So this is s. Please don't forget, not 5. These are s. They are the s domain. So they are not 5. So now we are done with the first principle, the first stage, that is applying Laplace. We have just applied Laplace transform to both equation. So this is the result of applying the Laplace. So but then there's one more thing you need to do. You know that these are x of 0, y of 0, and we're already given the value. So let's just insert the value. So we have x of s minus this x of 0 is 1. Then for this as well, 1 as well, the same thing, 12 x of s minus 1 over s square. So now let's try to connect like terms. Let the unknown stay together, then the known, let them stay together. So for this now, we have s x of s minus 3 y of s is equal to 1 plus 1 over s minus 1. Then for this, we have so y of s minus 12 x of s equals to 1 minus 1 over s square. So that's for this now. So now we are finally done with the applying the Laplace to the equation 1 and equation 2. So now you can say this is, let's name this our new equation 1, then our new equation 2. So as you can see, this look like our linear simultaneous equation, where we assume this x of s is a, then this y of s is b. So what we just need to do is apply. Now we are in the manipulation phase now. This is the phase where we'll simplify, try to manipulate with what we have. So now and we are doing this manipulation because we want to isolate x of s and y of s. So we'll be able to find them. They are the unknown we are trying to get. So now, as we solve our normal linear simultaneous equation where we use either substitution method or elimination method. So here now, I'll prefer to use elimination method. So using elimination method now, we are using elimination method. So now, how to eliminate x of s. So I'll be left with y of s. And to eliminate x of s, I just need to multiply the coefficients. I need to interchange the coefficients and multiply it with both equations. So now I will multiply equation 1 with 12, then and I will multiply equation 2 with s. So by the time I add them up, x cancel out. So that's what I'm going to do. Equation 1 times 12, then equation 2 times s, not 5s. So now with this now, we're going to be having, so for equation 1 times 12, we have 12s x of s minus 36 y of s is 12 plus 12 s minus 1. Then multiplying equation 2 with s now, this gives us s squared y of s minus 12s x of s is equals to s, then minus 1 over s. You know, s is s squared, so s times this 1x is striped out. So now this is our new equation. Let's call it equation 3 and equation 4. So I've gotten our equation 3 and equation 4 now. So see that now we can eliminate when we add equation 3 and 4. So add equation 3 plus equation 4. We're going to get like 12s, they are both the same, minus this, so they strike out. So I left with this. So I left with s squared minus minus 36 y of s is equals to, so then we are adding this, then we are adding this as well. So s 1 over s plus 12 plus 12 over s minus 1. So now let's manipulate again. So y of s is common. So now plus 12 plus 12 over s minus 1. Then isolate y of s, we have s over 1 over s plus 12 plus 12 s minus 1 all over s squared minus 36. So this let me simplify. This is s, not 8, not 5, s not 5, please. So now let me try to simplify this further and break it down. We have s minus 1 over s squared plus 12s minus 1 plus 12s all over s minus 1, s squared minus 36, that's the difference of two squares. So we have s minus 6 s plus 6. So we have this. So you can as well write this as, I can split it so that I can cancel out some terms there. So I can say s minus 1 squared plus 12s s minus 1 s plus 6 and plus is 12s. So we have s minus 1, s minus 6, s plus 6. So we have this then. We know that this s minus 1, then s strike out. So now we are left with this. So let me adjust so we can see clearly. So we are left with I of s is equals to s squared plus 12s minus 1 all over s minus 6 s plus 6. Then this s has been struck out, so we have 12 all over s minus 1 s minus 6 s plus 6. So now this is what we have after splitting. Then there's one more manipulation we're going to do. After we are done, we already have our y of s isolated. The next step is to apply inverse Laplace. So now, but when you look at it, this is going to look cumbersome. Let me try to apply inverse Laplace. To take inverse Laplace of this fraction, and this fraction will prove difficult and complex. So we'll try to break it down, and we will do that by turning it into partial fraction. We're going to split these fractions down into partial fractions. So now let me denote this first fraction. Let me call it I. Then let me call this second fraction. Let me call it J. So now let's first split the first fraction as is I. I now, which is square plus 12s minus 1 over s minus 6 s plus 6. So now to split this into partial fraction, we just have to take over s b over s minus 6 then c over s plus 6. So this gives us, take the LCM of this, it will give us something like this. Then we apply our simple simplification. We are left with s plus 12s minus 1. So now this a now becomes, we are taking these are the coefficients of the a, s minus 6, s plus 6. Then this b now, we are taking bs and s plus 6. Then for c now, we're taking these two, cs s minus 6. So that is it. Now let's try and get this a, b, and c value. So let s is equal to 6. You might be thinking, where did this 6 come from? It came from here because I'm trying to eliminate as much unknown as possible, so I can be left with just one unknown to find the value of that unknown. So now when I look at it, when I take 6, when I insert 6 here, everything here becomes 0. So this unknown is gone. When I insert 6 here, is 0. Everything here becomes 0. C is also gone. So we'll be left with only one unknown, which is b. So that is why. So now let's insert this here. Now anywhere we see s, I'm going to insert 6. So by doing that, we have this side will give us 107. And since this will give us 0, this one will give us 0. Inserting 6 here, 6 plus 6, 12, then times 6, we have 72. 72b, hence our b is 107 over 72. So we have gotten the first unknown. So let's get another unknown. Let's say s is equal to minus 6. So if I take s is equal to minus 6, where is going to this will be eliminated as well, and this will be eliminated. This only c will stand. So now anywhere we see s, we are inserting minus 6. So when you do that to this to this left hand side, you have minus 37. Yeah. C becomes 72. So C becomes minus 37 over 72. So for A now, let S equals 0. So now S here is 0, here is 0, here is 0, here. So I left this. And we see S when start is 0. So I left with minus 1 is equals to, when we start 0 here, that is 6 times 6, then negative. So we have minus 36A. So now A becomes 1 over 36. So our I now, this fraction I, after splitting into partial fraction, we're going to be having this. So now I've gotten ABC. Let's insert the value. So that we have our I. So we have 1 over 36s plus 107 over 72s minus 6. Then our C is minus. So minus 37 over 72s plus 6. So this is the value for our high for this first fraction. So now let's get this second fraction as well. So let's split it out. For G now, same thing. Splitting it into a partial fraction. S minus 1, S minus 6, S plus 6. So this will give us, split into partial fraction like this, we have A over S minus 1 so we're going to apply the same thing we did here. So here will be 12. Here will be S minus 6, S plus 6, B will be S minus 1, S plus 6, then C will be S minus 1, S minus 6. So doing all that, then first unknown that I want to find, same thing, let S equal 6. So yeah, there is no S here, so this left hand side will remain as 12. So now starting this here, we are left with what? We are left with only B, so that we was 60 B. So B equals to 12 over 60, which is 1 over 5. So now that's 1 over 4B. So another one, let S equals minus 6. So let S equals minus 6. So as I said, this left hand side will remain as 12. Then it starts minus 6 here. We are left with C. So that will give us 84C. So which means C will be equals to, now we 12 over 84, which is 1 over 7. So this is our C. Then the last unknown now, let S equals, we have what is S minus 1. So take equal to 0 and isolate S, so we have 1. So So now insert it here. So we are left with only A. So now it's on to 12 on this left hand side. Then we are left with minus 35A, which is now minus 12 over 35. So our J now, our J will be what? Starting the value of this A, B, and C. So our J is minus 12, 35, S minus 1 plus 1 over 5, S minus 6, then plus 1 over 7, S plus 6. So now this is for J. So we have split the two fractions here. So I and J. So now we just need to do is combine it to give us our y of s back. So I'm going to be adding this. I'm going to be adding this I and this J together. So let's move on in part 2. Thank you for watching.